Hey, hello guys, and welcome to my channel. Now in this video, I'm going to prove to you that the integral of cosine of x is equal to sine x without recalling differentiation. Now here we just talk about the integral of cosine x over the x variable, and we know it to be sine x plus c, alright? Now, we identify the fact that in a polar form of a complex number, when we have the real part, which is just cosine of x, and the imaginary part, which is just sine of x, alright? That the real part of that is just cosine x. So this is it, alright? So by integrating cosine x, is just like integrating the real part of e to the ix, where e to the ix is the Euler form of this polar form right here. Okay. So by doing that, we integrate cosine of x over the x variable. Is like integrating the real part of e to the ix, alright? And right there, we just go ahead and integrate this over the x variable, and we are going to have 1 over I, okay? You know, this is the coefficient of the x in the exponent, the x we are differentiating. We are integrating, sorry. So that means we're going to have 1 over that times e to the power ix, and we are going to take the real part of that. So that leads us to having the real part of, now, let me clean this up. So that takes us to having the real part of, now, e to the ix is the same thing as cosine x plus I sine x. So this is it. Alright? Now, from here, we can just say, okay, let me multiply 1 over I throughout in the bracket. And by doing that, I'm not just going to leave it like this in the denominator, okay? I'm going to take the I up by multiplying top and bottom by iota. I know that iota times iota in the bottom is going to be -1. And at the top, you're just going to have iota times 1, which is iota. So -1 in the bottom makes it negative iota, like this, right? So that just put this down. And we still continue to take the real part of that. So by considering this, we multiply this negative iota throughout in the bracket. We're going to have negative iota times cosine of x, which is negative iota cosine x. And again, negative I times positive I sine x. That will become negative I times positive I sine x. And you know that I times I is -1. That is, iota times iota is -1. And the negative of that -1 is going to become +1, which is just here. +1 sine x. So we go ahead and notice that this cosine has taken the iota, which makes negative cosine to be the imaginary part. And this sine is down the real part. So by taking the real part of this is sine of x. And since we are doing integration, we just go ahead and add a c right there. And this completes the proof. So this shows that the integral of cosine of x is sine of x. And we add any arbitrary constant to that. So that is how to do it in one way, in my own way, without recalling differentiation. So you can also put down your own way. Okay, thanks for watching.